When we say, for example, and I start from this, sterilization, practically what we mean is the process that kills practically any living microbiological form. On the other hand, the terms sanitation and disinfection, especially nowadays, have led to some confusion. As a matter of fact, if you see the term in its standard definition, as far as sanitation is concerned, it generally means disinfecting and cleaning surfaces. And what does that mean? That when there is a lot of dirt from both organic and inorganic matter, microbes, etc., generally we refer to cleaning and removal of this dirt. The disinfection component instead refers to the killing of microbes, and this killing of microbes can take place through different methods. One of these can be precisely light, and it can also be of a chemical type, and this doesn't mean, however, that disinfecting does not necessarily imply in itself removing. Is that clear? Therefore, sanitizing means disinfecting and removing. As far as disinfection is concerned, this is a technique that applies to different types of technologies. And this basically means reducing the microbiological component, and reduction that can be achieved by killing or removing, or, example, by diluting. These systems that act by dilution, that is, they decrease the presence of these microbes, and consequently, this is also a result of disinfection. A filter that mechanically blocks the microbiological components basically performs disinfection in some way. Therefore, they are a little more complex. Speaking of surfaces, I would say sanitation is correct. More specifically, the term disinfection is used in various types of contexts. Light, the visible light, that somehow we have all day long, has a wavelength of around 400 nanometers. A nanometer is 1/1000th of a millimeter, and so, of a meter, sorry. So it's a very, very small amount. The light around this wavelength creates in microorganisms, mainly bacteria, but also in other microorganisms, so also viruses, etc., some oxidative processes that affect, compromise the membranes and structures of microorganisms. And so they basically kill them. To use a term that is not exactly technical and scientific, but they do kill them, they deactivate them. The light around this wavelength creates in microorganisms, so they actually remain in the environment. So that's why my colleague, Professor Messina, has explained the concept of sanitation well, differentiating it, the concept of cleaning, etc. I would also like to add along these lines, not all languages translate these terms in the same way. So we have been given all the definitions in the Italian language. For example, in English, the terms have a slightly different meaning. Maybe my colleague may add something to this respect. Well, basically, put in a nutshell, we use the visible light, which is near UVA, let's say UVA light. So it is near UV light, but it's not exactly UV light, except with a small part which is manageable, as we said earlier. In terms of safety, on which SIDÈREA has devoted a good part of their project based on what we know, and somehow it acts with different processes from those of UVCs, which are some kind of nanometric scalpel. That is, in practice, they're like scissors that cut the DNA. In this case, however, the highest near UVA wavelength in the visible spectrum creates some oxidative processes. Therefore, in some way, it wears out. It compromises the structure of our microorganisms. There's one thing I can add, however, in this respect with regards to UVCs, as well as to near UVAs. You must remember you shouldn't disregard the standard actions required for sanitation or disinfection purposes because, as I said earlier, the residues of microorganisms that remain must be removed anyway. And in any case, is any type of technology that can be used must be used along with what is already available, and it is right that it should be used.